Okay. Where we left off, we calculated the z-values. We knew if the z-values were really, really far away, and being a far away z-value would be like greater than 2 or less than 2 standard deviations, then we know we're far enough away that the event occurring would be unlikely if the null was true. Okay, and we'd say, okay, the claim is bogus because my sample data is super far away. But then there was some gray area with some of our z-values, and we didn't know like exactly what value to find. Today we are going to be able to specifically say this is far enough away we can reject my null, because we're going to calculate a p-value, which will come from the z-value that we found. Step 1, to state the null and alternative hypothesis, we did. Step 2, describe the sampling distribution and calculate the z. That is what we did last class. Now we are going to calculate a p-value from my z-value. It's one extra little step. Okay? And what we will do is we will compare the p-value to this significance level. In the question that we will get, we will be given a significance level, usually 0.1, 0.05, or 0.01. Okay? If your p-value ends up lower than the significance level, we will be far enough away with our z-value. If the p-value is greater than the significance level, we will not be far enough away. Okay? Now, what is a p-value? The p-value is the percent that you find in your normal curve based on your z-value. So if you had a z-value that was like -1 or -1.2, we will calculate the percentage of our data that would be below there. Once we find this percentage, we will compare it to my significance level. And if it's higher than my significance level, let's say this is, I can find this really quick. This is 11.5%. We've already calculated this, so we're just going to remember what we've done in the past. This is 11.5% or 0.115. We will then say, oh, that is greater than 0.1. It's definitely greater than 0.05. It's definitely greater than 0.01. Since it's greater than these values, then we would say that a z-value of -1.2 is not far enough away. And that's it. If we get, say, a z-value that's like -1.5 though, well, let's look at what the area would be for a z-value less than -1.5. And I'll show you how to do this because you've already done it. This is 0.06. So 6% of my data is below -1.5. Well, in that case, it would be underneath the 0.1. And we would say, oh, it is far enough away if our level of significance was 0.1. If we're talking about a level of significance of 0.05, you would say, nope, it's not far enough away with that significance level. If you talk about a significance level of 0.01, you'd say, no, it's not far enough away from that. Okay? So it's just one way to be able to say definitively, yes, this is far enough away, or no, it's not far enough away. Okay? Now, how do we calculate the p-value? Well, remember from previous classes, if I want to find an area under a normal curve from a z-value to the bottom, I would use normal CDF. Everybody, get your calculators out. And let's find this 11.5% and this is 6% using our calculators. Remember, If we're talking about a normal curve, we said our minimum value was -10 and our maximum value is 10 for z values. Well, if I want to find this area here below -1.2, I would say, hey, calculator, tell me the area, second dister, remember dister, normal CDF, -10 to -1.2. And you guys have a little table that pops up. Just go from -10 to -1.2. Boom, there's that 11.5%. This is your p-value. It's your percentage of your data that is going to be in the tail below your z-value. Or it could be the percentage of your data above the z-value. We'll practice it, okay? Now, go ahead and find the 6% for a p-value that is less than -1.5. For a z-value that's less than -1.5. Good. Get 0.066 for -1.5. I'm just making it up. What do we get? Normal CDF from -10 to -1.5 is the z-value. You get that? Good. Okay, good. Now, what happens if I have a z-value that is greater than my standard deviation, greater than my mean? What if I have a z-value that's like 1.6? How could I find this area greater than this probability? Use 10 instead of -10, but remember that our low value comes first. So in normal CDF, you would go from 1.6 to 10. Find out this area here above 1.6. We should get 5.47%. Did we all get that? Go from 1.6, not 1.3. 5.4%. So 5.4% of data in a normal that is normally distributed would be greater than 1.6 standard deviations. Okay, good. All you're going to do is after you calculate your z-value, you're going to find the p-value, you're going to compare it to a significance level, and a p-value smaller than the significance level is statistically significant, which means it is far enough away, or your sample is far enough away, that you're going to claim bogus on the null hypothesis, because this observed result is going to be very unlikely to occur just by chance. Since it's smaller, it's very far away, a smaller p-value comes from larger z-values. Right? The further you are away, the smaller the tail percentages are going to be. This is just going to confirm things. If we are far enough away, we are going to reject the null hypothesis. If we have a p-value that is greater than my significance level, then we are saying that it is not far enough away. My sample is not far enough away for me to say that this null hypothesis is not true. We will not reject. That's it. Just do not reject the null might be true. go back to your homework. We calculated all of these z-values. What you will be given in the future is this problem, but you will say at the end of the problem, or it will be given to you, test this based on a blank level of significance. So they'll say, hey, use a sig level of 0.1. Maybe this says use a sig level of 0.1 as well. This sig level of 0.05. And here, let's do a sig level of 0.05 as well. Okay? Now, based on these z-values, you can calculate the p-value. Right underneath all of these null hypotheses, let's calculate the p-values. Everybody, figure out the p-value if your z-value is negative 0.962. What percent of your data would be less than negative 0.962? Compare your answer with a neighbor.
Okay, so we're just basing it off this, what our answer is.
We're getting our p-value based off of our z-value. Once we get our p-value, we will compare it to this. We get 16.8. Do we get 16.8? We get 0.168. Right? Okay. Since this is larger than this, we will definitively say that this is definitely not far away, and this could be true. We're going to fail to reject. Okay? Definitively. Now, there's no gray area. This is not larger than this. Fail to reject this. Okay? Okay. Next one. If the significance level is 0.1, and I have a z-value of negative 1.054, find my p-value and definitively say if we are going to reject or not reject this. We think that we are not far enough away, and that this could be true. We could fail to reject, but let's find out for certain. Go. Check your areas with your neighbor.
So should that not reject it?
Yep, just like we suspected.
Okay. Negative or positive?
Not 0.1. We'll go from negative 10 to negative 1.054. The p-value comes from the z-value. So fix it. Fix it. Nope. It's all right. Don't use the what?
You don't use the 0.1?
Nope.
So
we're finding the z-value, right? Our normal curve, the area under our normal curve is determined by our z-values that we use. Right? This is a z-value. We're trying to find this area here. It's based off of the z-value, not the mean.
Okay.
Okay?
So what's the point of stating this?
The significance level is just our definitive cutoff level.
Okay.
And our cutoff level will help us determine concretely if this is far enough away or not far enough away. Because right now we're just suspecting that it is. But now we will have a cutoff level. Okay? And that was the question that we asked, like, where's the cutoff level? And I said, well, it depends. Now we will have the answer. Uh-oh.
They were really good today.
What is the p-value, Mr. Champagne? 0.145. Did everybody get 0.145? Yes. Now, this is not less than this. This is definitively giving us proof that this is not far enough away for us to say that this isn't true. Just like we suspected, right? But now it's just we know for sure based on this significance level. Okay? Well, look at the next one. Negative 4.22. We know this is super far away. Watch what happens when we find our p-value. What do we get? Find your p-value for negative 4.22. What is your p-value for negative 4.22? $1.22 is incorrect. 1.22 times 10 to the negative fifth is correct. But what does that mean? No. What do you do when you multiply something by 10 to a negative power? It's a super small decimal. You move the decimal place over this many times to the left. This is 0.000122. 1, 2, 3, 4, 5. 0.0000122. Which means the likelihood of this sample value occurring is super unlikely if this is true, which is just definitively saying that this is super far away. This value is much, much less than any significance level that you'll see, whether it's 0.1, 0.05, 0.01. Since it's so much less, this is super far away. The sample is super far away. This can't be true. This is false. We reject this. Okay? What about 1.917? We're not sure, right? Well, if I have a significance level of 0.05, let's see. Are we going to reject this statement and say this might be true? Or could that original statement possibly be true? Figure that out. Now, this is a positive z-value. Remember, if we're talking about the positive side of our normal curve, if we're over here, we need to go from our z-value to 10. Right? Okay, make sure we do that. Check your answers with a neighbor. What did you get? 0.027 is what you should get. If you didn't get that, fix it. 0.027. This is your p-value. Okay. Compare this to the significance level. It's smaller, right? Which means this is far away or not far enough away. That's a big question. Is this far enough away if this is less than this? It is. Think about it. Larger z-values, smaller p-values. Smaller p-values, unlikely to occur, reject this. If you just want to go off of the z and look at the z and you say that z is crazy large because it's outside of 2, well then boom, we're far enough away. Here, 1.9, pretty far away. Well, there's only a 2.7% chance that it's going to happen or be a value greater than that. Based on this significance level, since this is smaller, we can reject this. This can't be true. Yep. Has to be smaller. Look, this one is smaller than this. We know that we're going to reject this because this is super far away. This can't be true. Well, this kind of confirms it. This is going to be told to you in the question. The significance level will be told for you. It gives you the cutoff point. The last one, the p-value is smaller than the significance level, which means this is far enough away that this can't be true. Okay? It gets a little tricky because it's this extra step, but it's really not that bad. It just confirms what we already guessed, that this can't be true. We're going to reject it. Now, however, watch what will happen if the question changed the significance level to 0.01. What happens? This value is now larger than this. If the significance level is 0.01 and this all of a sudden is larger, well, now we can't reject this because the cutoff point is much further away than it started at. Okay? The significance level is the cutoff point. This will be compared to the cutoff point to figure out if this is far enough away. Okay? So all of a sudden, since this is greater than, all of a sudden we would change our answer to can't reject it. Might be true. Okay? So it's one extra step. Find the p-value compared to a significance level, which is our cutoff point. If it is smaller than our significance level, it's far enough away, our sample is far enough away, our z-value is far enough away that I can reject this. If this is larger than my significance level, this is not far enough away, this is not far enough away, this might still be true. All right, let's do the examples on the back of this worksheet. Cellphone Danger. The American Automobile Association commissioned a 2003 study by researchers at the University of North Carolina on sources of distraction for drivers. Tracked 70 drivers aged 18 to 80 for a week. Many cameras were placed in the cars and their driving behavior was randomly viewed. The study found that 21 of the subjects used cell phones while their vehicles were moving. Is there significant evidence that fewer than 1/3 of all drivers use cell phones while their vehicles were moving? Carry out all 4 steps of the inference to answer the question, and what should be stated is the significance level, and it will be a random number they will select. I'm giving you the significance level is 0.1. All right, first we got to state our hypotheses. Well, I'll do it quickly for you. So we are figuring out that fewer than 1/3 of all drivers use their cell phones. That's what I want to show, that fewer than 1/3 of the drivers use their cell phones. That's going to be my alternative, that my mu will be less than 1/3. That's what I wish to show. In this problem, it's kind of not obvious because there's no like claim. Instead, it's just going straight to this is what I want to show. Well, that means my null hypothesis, my claim is that it's equal to or it's greater than or equal to 1/3. Simple just to do equal to. All right, now, it's your turn. We've done this so many times. Let's figure out our mean, our standard deviation, our z-value, our p-hat, and our z-value. After you find your z-value, find your p-value. Compare it to 0.1. Now make sure you're using 1/3, not 0.3. And use exact answers. Mr. Holtz, get your calculator and calculate the z-score. Don't use 0.3, use 1/3. Oh, you're okay, good. That's right. Your X bar is 0.3. Never mind. Negative 0.592 appears to be the correct z-score. Let's make sure we can get that.
Is that correct?
Yeah, you can do that.
Okay.
And then divide it by
Divided by
that.
yeah.
Good. Negative 0.592. Close enough. Good. That's the standard deviation. Okay. One-third. Perfect. 0.5916. Good.
Is that right?
It looks to be right. Yeah. Let's see. You rounded early. Don't round early. Ooh, let's see if that's right. So do this again.
So I just keep it all in there.
That's good. I forgot to take the square root. 0.056.
Good.
Yes. Should be your sample minus your guy divided by your standard deviation. What happened with your standard deviation? Right. So we use our hypothesis, our mean, not our sample mean. That's our standard deviation. Okay? All right. What was our standard deviation? 0.056 approximately. Our X bar was 0.3. What was our z-score? All right. Before we even calculate the p-value, look at your z-score. Is this telling you that the sample is super far away from your parameter, or is it pretty close to your parameter? It's pretty close, right? It's not outside of the twos. Okay? So immediately you can say, well, this might be true. I'm not going to reject this. It's not far enough away. But we go the extra mile, we find the p-value, and we compare it to the significance level of 0.1, and we definitively say it's not far enough away. We will not reject the null. Okay? Find the p-value if your z is negative 0.592. It actually will be the same thing if you do negative 10 too. Good. We should get 27.69%. 27.69%. Does everybody get that 27%? Because this is larger than this, we fail to reject that. Which means that what I'm trying to show, I can't. I'm trying to find significant evidence that fewer than 1/3 of all drivers use their cell phones. Well, I can't do that because my X bar is not far enough underneath 1/3 for it to be statistically significantly smaller. So I fail to reject. Okay? Next one. Now, I'm going to give you a tougher significance level. The significance level is 0.05, okay, for this question. Nationwide survey of 1,500 adults asked about the attitudes towards alternative medicine, such as acupuncture, massage therapy, herbal therapy. 660 said they would use alternative medicine if traditional medicine was not proved the results they want. Do these data provide good evidence that more than 2/5 of all adults would use alternative medicine? Well, what we are trying to show in this case is the alternative. We are trying to show that more than 2/5 of adults would use alternative medicine. So that my mean, or my P, is greater than 2/5 is a nice decimal 0.4. That means my null would be my mean is equal to or greater than or equal to 0.4. All right, do this problem all the way through. My mean is 0.4. My standard deviation is 0.0126. My sample mean, 660 divided by 1,500. What was that? 0.44. Okay, here's the deal. 0.44 and 0.4 seem to be close to each other, which means maybe the null is true. Maybe we are just going to be equal to or greater than or equal to 0.4. But we find out the distance in terms of standard deviations. What do we get for our z-score? Do it.
I did. I don't think that's right, though.
3.16. We get 3.16? Yeah, around 3.16, 3.17. Is this far away from the mean? So, do we think we're going to reject this? And most likely this is probably true. If it's far away, that means it is statistically significant. It is far enough away from this that this is not true, right? Since this is far away, we're going to probably reject this. How do we confirm it? We find the p-value. Normal CDF now we have a positive p-value, right? So a positive z-value, so we're going to go greater than 3.16. We're going to go 3.16 to positive 10, and I get this. What's that? 0.0007. Remember, times 10 to the negative, you move the decimal place over that many times. So your p-value is 0.0007. That means there's such a small chance that this could occur that it's got to be this is not true. Our claim is false. Our claim is our null hypothesis. Since this is less than this, we will reject our null hypothesis, which means that more than 2/5 of adults that would use alternative medicine could be true. And all this value is the cutoff point. It confirms that this is far away. All right? I'm going to give you your homework, and I would like you to start it, please, so that you can check to see if you're doing things correctly.
Good morning. These are today's announcements. Attention prospective Cal students of 2016-2017. Evaluations have been delivered via email to your teachers. Please take time to check with your teachers confirm they've submitted an evaluation. Evaluations are due Friday, March 11th.
All right, Cade, come over here.